Hey, algebra, what's that? I guess you've heard of that word, but have you ever looked at the meaning of it? Let's come up here now. And if we go back to the Arabic, algebra meaning reunion of broken parts. What's broken? I hope your knowledge of mathematics is not broken, mate. But anyway, let's go on and see what they mean by reunion of broken parts. And there are many presentations in this development of algebra now. So I hope you'll stay with Hadimas and have a look at how it all develops. Now here we are, the father of algebra. You could Google search this yourself. Is this guy, Al-Khwarizmi, the father of algebra? Well, my Arabic's not too good, as you can see. But he lived in Baghdad around 780 to 850 after the birth of Christ. And he was one of the first to write about algebra using words, not letters. I guess you might know already that we sometimes use letters in place of numbers to speak about patterns or broken parts and what those parts might be when you put them together in algebra land. And then he wrote this book from which we get the word algebra, meaning restoration or reunion of broken parts. This book included many word problems. Okay, so can you see that maybe this dude was about solving problems using mathematics and putting together the broken parts, the parts that made up the problem? What do you think of that? Okay, well, come on down. Let's have a look and see. Oh, no, what's this? What a mess. I Google searched algebra and I got this. And you can see a lot of broken parts there, mate. There's all sorts of things that you wouldn't even know. What about inequalities? Oh, I don't know nothing about, well, I do, but I don't think you will at the moment. And numbers okay, expressions, I don't know. How far have you gone with this stuff? So, yeah, certainly a lot of broken parts, lots of different parts to algebra. And what we want to do now is to have a closer look at what we can use algebra for. So come on down and I'm going to tell you about how I asked a group of very smart students, similar to yourself there, about what was the meaning of algebra. And some said it was about solving puzzles. Others said it was about X. What's X? X marks the spot where. And if a pirate's hidden a treasure, I guess that's where they mark it on the map. That might not be what algebra's about, I don't think. And finding the unknown was another response I got from a group of young students. Finding the unknown. Oh, that's interesting. And then the other one was solving equations. Hey, that's getting a bit techno. Solving equations. So these students all had different experiences with algebra or about algebra, and I suppose putting all the broken parts together, I don't know. So let's have a look now at, let's start with this one, because we found that the father of algebra, I'm not even going to try and pronounce his name now, but the father of algebra tried to solve some problems using words and stuff. And so let's do this puzzle sort of stuff. So I've got a puzzle for you. I've been thinking about this little puzzle for you because I want you to get excited about this. So here's the puzzle. Watch me put it on the screen now. I think of a number. Okay, I think of a mystery number and I'll put NO dot for number. I think of a number. So the puzzle's starting. It's all about you trying to work out what this number was that I thought of. I double it. Okay, I double the number. Okay, I add 5. Okay, so there's your puzzle, and the answer is 17. Okay, so that's your puzzle there. And what can we do to put all those pieces together? Maybe that's what the guy was talking about with putting together fractured pieces or stuff like that to solve a puzzle. Okay, so let's have a look at one way we could look at this. So have a look at this now. Let the missing number be, well, you could let it be X or N for number, whatever you like. And what we're going to try and do is to track through what's going on here in Mathland. Okay, so I think of it, I double it. Doubling anything is timesing by 2. So 2 times x, I just doubled that mystery number. Then I'm going to add 5. So can you see I'm tracking through here? That's the mystery number. Double it, add 5. And the answer is, I guess you already know a little bit about maths. The answer is probably best represented by equals. The answer is 17. How beautiful is that? All these words up here we've put into a mathematical sentence. A mathematical sentence, which is a lot neater than all this stuff. Have a look how neat it is. Wow. That little line here in Mathland describes all those words. It describes the same thing that fractured those pieces that we're trying to put together now. Can you get the idea here? This is an important start. So we've got 2 times the mystery number plus 5 is 17. Hey, that's great. But how can we work out what the mystery number was, the number I thought of? Let's unpack it. What was the double the number before we added 5? Let's take the 5 away. So we would have just got 2 times the number. Notice here I'm sneaking up on you. I've left out the time sign. And that's a little rule of algebra to make it look neater. Instead of 2 times x, we can just write 2x. And what was it before we added 5? Well, let's take 5 off from 17 and backtrack. Hey, before we added 5, the double of the number must have been 12. Now let's unpack this side. Double the number is 12. Let's undouble it. Oh, I don't like that, mate. Bad Huddy maths. Undouble it. Undouble it. What would be undoubling in Mathland? That would be the same as divide by 2. Okay, divide by 2, hey? So let's divide both sides by 2. X is 6. I think we've just done it. We've put all the pieces together in algebra land. But we should state, we introduced this idea of x. The problem was couched in terms of what was an original number. So what we're going to say here is, therefore, the original number was 6. No good giving x equals 6. X was our concoction, our algebra method of trying to solve the problem and put all the pieces together. So we should state it in those terms. Okay, because we were asked what was the number I thought of. Okay, so shouldn't you check it out? I think we should check out that works. So let's just check it now. Checking. I think of a number. Here we are, back up here. I double it. So 2 times 6 plus I add 5. And let's check it. 2 times 6 is 12. Plus 5. Oh, it works. I'm going to give that 2 ticks. Hey, how long since you got 2 ticks for one answer, mate? Anyway, it's 17. We would say which checks. How about that? How beautiful is that as a mathematical procedure there? Let's go back up and let's check out those students. I thought they were pretty smart, these students up here, who said it's about puzzles. Yep, we've just solved the puzzle. It's about finding the unknown. Hey, what do you reckon the unknown was in this puzzle? It was the number I thought of. And what about x? Well, it's about x if you use x to track through what's happened to your mystery number. So we'll give that a tick, and we'll give that a tick. What's this one here? Solving equations? What? Oh, well, that's a word for a mathematical sentence where we put everyday language into math terms. Mathematical sentence or equation. So there's maybe the first equation you've ever written. Here it is here. Is that your first equation? Hey, get excited about that. The first equation, perhaps, that you've ever written. Equation, equating. There it is. Quite simple language in mathematics. It's always commonsensical math language. So equating is where that comes from. We're equating or saying this side is equal to this side. And then we backtrack and unpacked it. Well, I hope you can see what's going on there. And what I want to do right now is put a little advert in for the Huddy Maths hierarchy of learning. There is a process or an algorithm, a method by which you do the problem. I want you always, when you track through this, to say, well, what's the idea? What's the concept? What are we trying to do? And the idea here, the concept, is to undo the operations, don't we? In the reverse order to what they're doing. And do you want to see it? I want you to get to the point where you say, hey, I see how to do that. I actually get that. I'm not just copying the teacher in monkey fashion. Monkeys tend to copy each other. I'm not going to do that. I want to go up here. This is called Huddy's hierarchy of learning. I want you always to try to get to the top of that. To say, hey, I really can see what's going on here. Okay, so maybe to get this better idea, I see it, I could do it for you in a different way. Just come down here a little bit. We'll just make a little gap down here. And I want you to see the level of understanding I want you to get at. So I want you to say, hey, when's your birthday? Okay, tell me when your birthday is. And what I'm going to do is I'm going to give you a present. I'm going to put it in a box, hey. I'm going to put this in a box. And what's your present going to be? Well, what would you expect from a maths teacher, mate? I'm going to give you X. What else could I give you? A maths teacher's obviously going to give you X. So I'm going to box it. I'm going to give you a present of X. You don't know what it is. That's part of the fun. I'm going to put it in a box. Then I'm going to wrap it up. Okay, I'm going to wrap that box up so it looks like a really good present. Wrap it. And then I'm going to put a ribbon on the top. Okay, you've got to have a ribbon, mate. Here you go. A ribbon around the whole box. I'm going to ribbon it. Now, you know, I guess you realise maths teachers don't get paid much, so I can't afford one of these baubles on top, you know, one of those. Nah, can't afford that, mate. I think you're worth it, but no, I can't afford to give you one of those, so I'm just going to ribbon it. Now, you want your little old X in here. So how are you going to get back to X after all this stuff has been done to it? Well, you're going to go in reverse, aren't you? Just like we did with the mathematical operations. First thing, take the ribbon off. Now keep that to the side carefully. You might be able to use that for your brother or sister's present later on, hey? Don't just screw it up. And then we'll take the wrapping paper off, we'll unwrap it, and then we'll take it out of the box. Being careful to keep all these things, because you might want to use them for later gifts to other people. You never know. You should always conserve stuff. Okay, get the idea. Do you see how you can understand the reversing of those steps in a very, very easy way so that you actually see, hey, I see it. I see it. And I is very important. That's you, mate. I actually see it. How fantastic is that? If everything that you do in maths, you could bring back to that level where you actually get it. All right. Are you ready? You might have to replay this video and check this out again because I want you to do some for yourself now. And so here we go. Oh, way down here, I've got for you your problems. And you can look at the answers, I don't care. I don't really care about the idea of getting the answer. I want you to have a method of solution. And remember Huddy's hierarchy of learning. I want you to actually not just guess it. I want you to go through a process where you can see the idea and therefore really get what's going on rather than just guess the answer. So I want this solution to involve mathematical sentences like we spoke of before. Mathematical sentences which in later maths are called equations, where you actually are using a mathematical process to get the solution. Don't just guess it. We're not interested in the answer. We're interested in what's the concept, what's going on in your head. Are you really putting all these fractured parts together and finding out the answer? So there you are. There are 4 problems there. And I want you to try and do it the same way as what I've done it back there and try to get up close and personal with maths because that's when it's fun, when you get up close and personal and you really see it. Well, I look forward to taking you on the algebra journey in future presentations. There's one coming up which is really, really interesting, comes at it from a different angle, and I look forward to seeing you there. Okay, so for now, it's cheers for me. Catch you then.